In this video, I will talk about linear movement. For this, we use hydraulic cylinders. A hydraulic system is the best choice for creating linear movement. No other type of machine can match a hydraulic machine in this area. I will explain the machine's functionality by showing how different variants of hydraulic cylinders work. At the same time, I will explain about hydraulic symbols. This is a single-acting hydraulic cylinder. By that, I mean it works hydraulically in one direction while working mechanically, with the aid of a compression spring, in the other direction. This cylinder works hydraulically in what we call the plus direction. This is the direction in which the piston and piston rod moves out of the cylinder. Here you see a sketch of this type of cylinder. There is no hydraulic pressure in the cylinder in this state, and the spring has pushed the piston and rod back to what is called the minus direction. When we open a valve and let oil into the cylinder, pressure will start to build up on this side of the piston. The pressure will gradually build up until the force created by the pressure is greater than the sum of the forces created by friction, the spring, and the force needed to lift or move the load. The piston will then start moving, and oil will flow into the cylinder, as illustrated in this animated clip. Now we see that there is hydraulic oil in this chamber, and in this chamber here there is only air. There is an opening, or a port, on the minus side of the cylinder that allows air in and out. In many cases, this port is fitted with an air filter to prevent contaminants entering the cylinder. Sand and dirt can reduce the life of the cylinder. When we release the pressure on the hydraulic oil, the spring will push the piston and rod back and at the same time force the oil out of the plus chamber of the cylinder and back into the tank. Hydraulic cylinders have rubber seals that are leak-proof. As long as a seal is in good condition, it will not let oil pass the piston. And as long as no oil leaves the cylinder, the piston and rod will stay in the same position. If a hydraulic cylinder is sagging, it can leak oil through the directional control valve, or internal leakage can occur over the piston. In this case, oil will move from one side of the piston to the other, and the piston and rod will move accordingly. Here we also have a single-acting cylinder, but the spring is on the other side of the piston. This cylinder functions in the same way, but this cylinder functions hydraulically and is stronger in the minus direction. This type of cylinder is used for pulling. The symbols are logically designed and easy to understand. It looks like a simplified hydraulic cylinder. This is the piston, and here you have the piston rod. This symbolizes the spring. With this hydraulic symbol, the spring is on the minus side of the cylinder. This dotted line illustrates the port for air entering and leaving the cylinder chamber. This arrow symbolizes oil both inside and out of the plus chamber. This symbol here, where the spring is on the other side of the piston, looks almost the same. The spring is moved to the other side and the air and oil ports have swapped places. This is a sketch of a simple Boole-acting hydraulic cylinder. This cylinder has two ports into which oil flows. When pressure is building up, there is no spring force to overcome. The piston and rod will therefore start to move when the force created by the pressure working on the piston is greater than the friction and the force needed to move the load. A double-acting cylinder like this will always be stronger in the plus direction than in the minus direction. The reason is that on the plus side of the piston, the pressure will work on the entire area, while on the minus side, the area of the piston rod will work in both directions and will cancel itself out. Therefore, when calculating forces, we need to subtract the area of the rod when the cylinder is pulling. It is the area around the piston rod alone that contributes to the power in the minus direction. The speed, on the other hand, will always be higher in the minus direction than it will be in the plus direction. The reason for this is that in order to push the piston and rod out, we need to fill this volume with oil. To run the piston and rod all the way back, we need to fill this volume minus the volume of the piston rod. Thus, with the same volume flow through the directional control valve in both directions, it will take longer to fill the plus chamber than the minus chamber. So, double-acting cylinders like this are strongest when pushing and fastest when pulling. The hydraulic symbol is almost the same as for a single-acting cylinder. The spring is removed and there are now 2 ports for oil. This cylinder here is also double-acting, but it has 2 piston rods. It is called a balanced hydraulic cylinder. The pressure works in the same areas on both sides of the piston, and the volume in the plus and minus chambers is the same. This cylinder will consequently have the same strength and speed in both directions. You can see it on hydraulic steering systems on boats. If it was designed with 1 piston rod, you would need to turn the wheel more in one direction than in the other in order to obtain the same angular difference on the motor. With this design, 1 turn of the wheel gives the same steering effect on the motor, regardless of the direction in which the wheel is turned. This variant can also come with 2 different piston rod diameters. Then you would experience some of the effect I talked about in relation to the cylinder with 1 rod. In this symbol here we have 2 piston rods. Other than that, it looks the same as the symbol for 1 rod. This is a telescopic cylinder. In this cylinder, pressurized oil accumulates in the bottom. The pressure will work on the whole area that is covered by the cylinder pistons. The largest cylinder will move out first, as this has the largest area and will create the highest force, followed by the inner cylinder. The middle cylinder will bottom out in the outer cylinder, and then the inner cylinder will start moving. There can be more cylinders than those shown here. When compressed, this type of cylinder will create a large stroke compared to its size. Its symbol looks like this. It is drawn to show the functionality of the cylinders, but it is very simplified. Telescopic cylinders can also be made to be double-acting. In that case, they can both push and pull, but normally they are made to push only. You can see them on trailer dumpers, where they are single-acting. In this case, the weight of the empty trailer dumper will compress the cylinder as the pressure is released. A big thank you to all who speak warmly about this course. I really appreciate it.